This is Paul Wilson.
Chris Emke.
You're listening to the Diesel Performance Podcast. We're rebroadcasting all of our old L5P knowledge episodes now that the L5P is back up and so much hype is built around it.
I think like the value of the truck just went up. Like the value of a vehicle shouldn't go up because of what custom tuning's capabilities are, but I really feel like there's certain trucks that go up and down in value based off of support.
Well, I do feel like there's this sales guy somewhere who has sold 3 L5Ps in the last 5 days, and he's like, man, I don't know what it is. I'm just really good at selling these Duramaxes.
And they just so happen to be all 25-year-old kids.
So the L5P, here's what you need to know. Number one, HP tuners can unlock your ECM. At that point, it is permanently unlocked, and the only software that's going to flash it is HP Tuner. So dealership's not going to work. No. There's some discrepancies in the industry right now about VATs.
Yeah.
Vehicle anti-theft security. Whether that'll be able to be turned off when you receive your ECM or whether you'll need a dealership tool or a Tech 2 to program that. Sounds like it's going to get easier for customers, but we'll see how the details shake out.
You know, and one of the things, it's a touchy subject right now, but a lot of buzz on the internet's cost.
Let's hit it, man.
Let's just hit it, you know. So
unlocked ECM,
$2,500.
MPVI2 cable, which is the HP Tuner's cable.
Their suite. It's $300.
Licenses for HP Tuners,
500 in credits. So you're $3,300
without owning a tune,
just to support a calibration. Now. Yep. Tuning costs is speculated that's in the air right now. You know, it is still fresh, but
it's not going to be cheaper than an LML.
No, I'm going to be hated for saying this, but there's going to be some guys that listen that are going to understand this reference. The diesel industry as a whole, I think, have been very spoiled with what support and what protocols there are for flashing ECMs.
We were talking about this. Okay, go.
And you know, for me myself, you know, I came from an import car background into diesels. Been around diesels for a long time, and a couple of years ago, I decided I wanted to build another car.
Stupid.
Well, I underestimated the cost, but when we're talking about the cost, you know, to tune my 2006, just the standalone ECU with all the auxiliary inputs, that was $3,500 just for the computer and the auxiliary inputs.
Yeah, no tune.
No tune. And then I have a guy that, you know, is local to us that has the same dyno that we have a good relationship with, that did all the tuning and whatnot. But what you're finding
is... What'd the tuning run you?
Well, Adam and me, we work closely together.
What would the tuning retail at?
The tuning dyno session like that would be around $1,500. Oh! So, yeah, you know, to tune a $20,000 car with a $20,000 motor and everything else and a little 4-banger at that with all the supporting stuff, you know, you're going to pay. So when you think about the cost, is the tuning really? We're talking a $70,000 truck, $60,000 truck.
Let me give you some pushback on this, Chris. Okay. Not that I necessarily want to take this stance on the topic, but let me just tell you what I think somebody's going to say. And that's number one. On that car, you're buying it to build it, and it's a race car at that point. So it's a hobbyist vehicle, right?
Very much so.
So the guns I have in my gun safe, you could never rationalize the cost because they're a toy. I mean, guns are not a toy. That's not what I'm trying to say. But they're a luxury item.
It's a novelty.
Oh, it's a novelty. Yep. It's a luxury item. When I look at tuning, right now, tuning in the diesel industry has been very purpose-driven. So are we going to see...
a novelty.
Are we going to see only guys buy tuning who see it as a novelty, who see it as a luxury item? Because I feel like there's a lot of guys right now who they say they just want the basics. They just want a simple, affordable solution. Yeah. So are you telling those guys they're in the wrong market?
I'm not going to say that they're in the wrong market, but I'm going to tell them that they should have bought a different truck.
Damn.
Know what you're getting yourself into ahead of time. And I mean, we're adopting practices that Germany and over Europe, they've been doing this for years already.
Yeah, ECU exchange is real big
Go buy a new fucking Audi TDI.
Yeah,
or a Mercedes TDI.
Even my X5, it's send an ECM in to get it done.
Oh,
bench flash only. Yeah.
Right. And how much is that?
Yeah, it was pricey.
Right.
I want to say you could get it more affordably, but I want to say $750 was pretty standard.
So, and let's put a value on your SUV of $18,000 to $20,000.
Sure.
Okay. Now we're talking a $60,000 truck, $70,000 truck.
3 times the cost.
That literally support is just going live. It's going to be expensive. You're going to have the early adopters. You're going to have the people that are going to wait. You're going to have the people that have the early adopters give feedback to see a value to sell those guys on that.
Sure.
But yeah, the race car, my car, it's not a daily driven vehicle. It sits in the garage. It gets 1,500 miles put on it a year. I don't need it. I wanted it.
Right.
L5Ps drive off the showroom floor every day. Guys that are tuning it don't need it. They want it. Ooh. Are there values? Yes, there are values to having a tune. Improved drivability, shift quality, throttle response, horsepower, torque output. But the trucks operate just fine stock, just as your LB7 did, your LLY, your LBZ, LMM, so on and so forth. You're seeing that throughout all these RPOs, tuning costs get more expensive.
Yeah.
And the parts to modify them get more expensive.
Yeah, well, I think that's the other thing to put in mind here is we look at the value of what it is to do this. There's also the cost of not doing it, right? Mm-hmm. So I've had guys ask, do you think it'll pay it for itself in fuel mileage gains? Probably not.
No, I mean, let's be real.
Deleted or intact, I would have that same answer. I don't think fuel mileage. I don't think there's a way for this upgrade to pay for itself. If that's the modification you're looking for, there's probably other modifications out there we could talk about.
I look at it, granted this is L5P week, but look at my 15 Cummins. It's got
Nobody
twins.
cares about your Cummins, bro.
Right. It's got compounds. It makes good power. It gets good mileage. It makes good. It
does.
It runs really well. But I would never.
It before you owned it, yeah.
I would have. You don't invest the money into that because of efficient. Like it is efficiency, but it's not because of mileage.
The twin kit was never going to pay for itself.
It's drivability. It's the ability to tow. It's the ability to get up around the guy in front of you efficient and effectively.
Yeah.
You know, granted the truck, emissions equipped, 18 and a half miles to the gallon, mixed driving on average. And you're going to see that across the other platforms. We've seen that with the LMLs. We're going to see that with the L5Ps. I don't want to leak out too much information, being that, you know, we see the R&D and we've experienced what we've already experienced, but you're going to see that as the platforms progress, there's a lot of value there.
Well, you know, I think one of the things to really drive home here is how much guys love the LML. We're obviously very comfortable with the LMLs over at Duramaxtuner and on Diesel Performance podcast. We've done a lot of episodes around them. Working with Nick back in the day when he was, again, the first one to tune in LML, I got to be here for that, so it's been pretty cool to see him be at the leading edge.
First emissions equipped LML. Remember the 11 Denali to where it was to where we are at now with Jason's LML with that twin kit? It's just crazy. It's crazy.
So to be able to see these things firsthand has been really cool. But I know it has had me thinking about what are the differences from an LML to an L5P. There's a lot of guys out there who have been saying that once the L5P was tunable, they were going to go trade their LML in and go get one because now they can get a tune for it and they can do whatever they want. I thought before we saw a ton of guys go and trade in their LMLs, although I do hope so because I'd love to pick one up for myself. And if we could see the market drop on those, that would benefit me personally. But we're not here to screw over our listeners. We want to help you guys out. We did a great episode with Gale Banks back in the day, L5P and LML comparison. So we wanted to bring that episode back to you guys for L5P week here at Diesel Performance Podcast. Go ahead and give it a listen, and we will talk to you again tomorrow.
Hi, this is Rich with the Diesel Performance Podcast. This is audio from a video that we've posted on both Facebook and YouTube. I wanted to let you know that because during this episode, they will be referring to specific things, talking about what they look like. So if you're curious, just switch over to Facebook or YouTube and check out the video. Thanks again for listening.
We actually just got to see the L5P run at full tilt on the engine dyno. It was so cool to see it make 485 horsepower. We're going to be one of the first group of guys to actually see this thing run for that period of time, making that power.
To see it run and to see the analytics on it, to see how, I mean, the thing's not even working. You know, 21 air-fuel ratio, not even 30 pounds of boost. I mean, not even 800 degrees is temps.
Exactly.
GM's got 500 horse in this thing, no problem.
Easily.
Now that we know we got a lot more on the table, we got to see it run, we got to hear it run, let's go take a look at this thing broken down.
Yeah, absolutely.
Awesome.
Okay.
Hey guys, we're over in the engine room at Banks Engineering. Nick and I are really excited to go through some of the actual hard parts and the differences from the L5P to the LML. An awesome facility because Gale has it all broken out for us. So I think, gentlemen, we're going to start with the turbochargers. We have an LML turbocharger and an L5P turbocharger. Gale, right away, I'm not the tech guy, but I can see a few differences right off the bat. Walk me through what we're dealing with here.
Well, basically, they're both variable geometry turbochargers. The old one is a Garrett, and the new one is a Borg-Warner. This guy's been around a long time.
He's been around a long time.
In various sizes and shapes.
And I think it's cool. Bring it forward a little bit and show, because this is
so
one piece.
Essentially, the control of the geometry here is oil pressure.
Yep.
The control of the geometry here is motor. So this is quicker than that.
I would venture to guess maybe less failure prone. Like
it's a pretty rugged
sealed
piece.
Unit. Yeah, it's a rugged.
Yeah.
Yeah.
Yeah. Being the Borg Warner guy, Borg stuff is good. Garrett stuff is good.
True. True.
What we've got here is more compressor. This is a much higher use of EGR. That every year we got more and more.
Yep.
So both turbochargers are intended for EGR. In other words, the trim of the turbine is tighter than you might want to run on a performance turbo.
Okay.
Garrett guys have enlarged turbos here. I guess it'll be up to us to come up with something and working with Borg for this.
Yeah.
Or maybe they'll do it on their own.
It's all about airflow.
The turbo's farther forward on the engine on the L5P. But the up pipes are very similar to everything previous. So this mounts in the valley. The turbocharger has a more conventional 4-bolt pattern. They put a couple of pins to align it properly. Turbo does not sit square to the engine, and it's slightly canted.
Right.
To make their clearance work. This is the oil-air separator, oil fill point that's on the rocker cover. This is very cool in that boost air drives the oil back into the valve cover.
Really?
So you get virtually nothing coming out of the breather.
Yeah, so people who are running Duramaxes, typically you look at the intercooler hoses and you're seeing those intercooler hoses. You're seeing the oil around the discharge of the turbo.
Exactly.
You're seeing the oil around the intercooler. With this, no more.
And consequently, the oil mileage is better.
Okay.
In other words, you're not losing oil at the same rate and burning it in the engine. They did a couple of iterations of this. This is quite a piece. Centrifugal separation. Beautiful thing, but canting the turbo helps clear all the stuff on, on that valve cover.
So let's talk about the basics of the turbocharger for the guys who are buying, 445 horsepower up from 397.
Exactly.
Clearly, there's a bigger compressor wheel in the thing, right?
Yeah.
Have you guys measured the turbine?
Have we measured the wheel?
Yeah, the
no,
turbine
we haven't.
wheel. Okay.
No, we haven't.
I would assume it's bigger, but that'd be interesting to see as well.
Yeah, I wouldn't. That's an assumption I'm wondering about just talking about it here. And our development, I mean, you could do a visual.
Yeah, it doesn't look much different.
If anything, this might be a bit bigger.
Yeah.
I mean, you've got higher mass flow going into the intake manifold, so you've got a lot more coming out the exhaust side.
Yeah. It's interesting, the flange size too, because on the L5P they have that big DOC filter, or DOC, sorry, right off the turbocharger. You can clearly see the downpipe flanges.
Yeah, this is pretty close to 5-inch. There's a cat right here.
Right.
So they push the turbo forward and put a cat converter right off the turbocharger to get light off real quick.
Yep. Smart move, keeping all the heat in one.
Yeah. Their emissions work is profound on this engine. It's really good.
Yeah.
And they plan for the future. So as we'll find out in the dyno room how far we can go with this turbo. We'll do that today.
Yeah.
So we'll know. I'm afraid of turbine choke. In other words, you get to a point where the velocity somewhere in the housing or in the wheel goes sonic. In other words,
supersonic.
Yeah, and then pushing with more here might not get you more out of the compressor.
Right.
We're going to explore that a little
backwards
bit.
deal.
Yeah.
Yeah.
So you're going into turbine choke. You're done. You know, you can push it further, but you're going to damage the engine.
Well, exciting thing I see for the aftermarket, I think, too, is this two-piece setup. A long time in the aftermarket, we've seen these pedestals, right?
It's begging for it.
It's designed for it. I think it makes makes swapping the turbocharger certainly a lot easier.
Absolutely.
If that's something we're going to get into down the road.
I don't know, man.
I say
looking at a fully dressed L5P, swapping the turbocharger looks like a nightmare.
It looks like work, but hey,
well, for
duty
us,
calls, Paul.
We look at it differently in that, we might come up with a stock position setup. We're definitely going to do a different pedestal.
Yeah.
Because we're not constrained by all the other stuff.
In your military program you're talking about?
In my street program.
In your street
Not
program.
for production pickup truck,
Okay.
2017, but for any kind of special thing you're building.
Okay.
To be clear, non-emissions.
Yeah,
trucks.
our program has always been, we've got a commercial off-the-shelf engine with the LMM, the LML, and now the L5P, but we never pushed it.
Yeah.
This engine has got so much going for it, and we've been able to do our own lower crankcase, our own oil pan, our own windage control.
So packaging-wise,
Right. The engine comes to us with our stuff installed in the factory as a long engine.
yeah.
And then we can dress them for marine, we can dress them for your hot rod.
Right.
You want to put one in the Chevelle?
Yeah.
You know, I mean, what do you want to do?
So depending on what the
Or
application, the
military.
turbocharger can be
Motorsports as
adjusted.
well.
Yeah.
So we're going to be doing versions of the L5P for everything.
I like it. I
Yeah,
like
awesome.
it. Well, we got the turbocharger stuff situated, right? We got air in the motor. You're an airflow guy. You
Yeah.
love airflow, but we need to light it off with something too. And there's a big change on the injector side for the L5P.
Indeed, and it's a sea change because GM has gone from Bosch to Denso. And it used to be Denso injectors were a lot like Bosch.
Right.
It was remarkable how close they were. No more. This is a whole new avenue, and if you take one of these apart, we've got a program going to update these, modify them.
Okay.
But we've already got about 20% more injector flow.
Just
Available
factory
to
on the
us.
L5P, you mean?
Yeah.
Okay.
Wow.
So
Yeah.
just go from the LML.
There's
20%
more flow
flow.
capability here than there is here.
Okay. At a
This
certain
being
injector on time.
This is an LMM. We don't do the
You guys don't have any piezo injectors program,
no.
right?
no. Our LML engines have a heads machine for the LMM style injector.
Okay.
Solenoid.
So
Yeah.
guys in the aftermarket, though, or guys who are modifying their trucks should know the LML has a piezo crystal injector, which has a totally different control system. The Denso is now back to solenoid injector style.
Right.
So we're using a different control system than the LML used. Essentially, the older technology. The piezo was a big change for a number of injection events, but now Denso says they can do 5 or 7 or whatever with a solenoid
Exactly.
injector. So here we go.
Well, I think it's interesting too because when we went to the LMLs, we rated those stock injectors for a higher peak power. I don't know if they necessarily were flowing more fuel or if there's just a
The
difference in...
aftermarket took a long time to figure out the delay between injection on time and injector open time.
Right.
There was a big difference on a piezo crystal injector between how long you energize it and how long it's actually on.
And how many times you can open and close it in rate shape.
Yep. Yeah.
So I love
drive
it.
signals totally different.
Truthfully, I love the PSO.
Yeah.
And my ECU is solenoid.
That's the challenge, right?
Yeah.
Is there's no motorsports ECU designed for piezo injector that I know of.
Bosch might. You know, their $8,000 or whatever it costs ECU, I think, has a piezo capability. We'll see.
Okay. Okay.
I don't know
Yeah.
anybody running it. A piezo injector, right? Because anybody in a standalone unit from Bosch is
Well,
running huge
LBZ,
horsepower.
LMM,
Yeah, or
There are
whatever they're
guys.
running,
There
right?
are guys running piezo system with a 3.3 pump.
That we have a lot of.
Very common.
Yeah, the
Yeah,
very common.
3.4 being somewhat unreliable.
Right.
I'm told.
Yeah, CB
Yeah.
4.2 on those. Yeah, a lot of known
I'm sorry,
failures.
4.2.
Yeah, a lot of known failures out there with the CP 4.2. We've talked about it on the
Yeah,
podcast
yeah.
before. Honestly, there are some things you can go back and watch some of our previous episodes or listen to some of our previous episodes about running a lift pump and some other things you can do to help those be a little more reliable. But if we're talking about power application, now we've been through the turbo, the injectors, like you said, the pump is really the heart of it, right? Because if
Indeed.
we don't have enough pump, everything else doesn't matter.
And if we don't have enough, it's not just not enough, right? It's the pump is the first thing in the system. So
Right.
if the pump fails, you got a lot of expensive parts downstream, and they're all going to eat that metal, eat that carnage. So you know the CP 4.2 it always had a bad name in the aftermarket because when it fails, it's a really expensive day.
Yeah,
Yeah.
you might be buying injectors too.
Right. Exactly.
Yeah.
Exactly. So it looks like GM took Q on that, or you know,
Well,
changed to Denso, right? Something
The whole
different.
thing is Denso. We have a direct relationship with Denso as well as Bosch, so it's good with us.
Yeah.
Basically, comparing the 3.3 to the Denso, these things out of the box make about 1,087 cubic mils per rev.
And what you mean by that is every time it spins over, that's the fuel quantity that
it's its
pumps.
maximum.
Right.
Of that, 20% is returned to the tank.
Okay.
These have about a 20% return proportion. You can hot rod one of these, poke and stroke, get around 1,500 per rev. But when you get to 1,500, you back out 300 as return, and you're at 1,200.
Sure.
Right.
Okay. With the Denso, we've got a situation where we're 1,200 going in and about 10% return.
Okay.
Just screwing around, it looks like the Denso can go to 1550. And change in cam, maybe 1750, somewhere in there.
So we're talking 15, 16, 1,700 horsepower worth of fuel
Well,
with a stroker setup.
Your return fuel being only 10%.
Yeah.
And there's one more secret part of this deal. 2,500 bar.
I like that.
Really?
I like that.
Yes. This thing will go to 2,500 bar.
Okay.
So there's overhead to get more horsepower, to meet emissions, to get the finer particulate size that you get with
higher fuel pressure.
higher fuel pressure. But if you're into power, that's a good thing there.
Absolutely.
As well.
So, I mean,
So if you've got a dynamic range, from idle fuel to 2,500 bar.
You can run a smaller injector, maintain great drivability. You can go higher fuel pressure under heavy load, and then it essentially changes the injector size dynamically.
There's a rail pressure sensor out there, same metric thread on the L5P as on the earlier stuff, that goes to 2,700 bar.
Yeah, we've been using that, Gale. We've been using that. That's a nice piece.
Yeah. And where guys used to just cap it up,
Yeah.
Turn that code off.
Good way to go, boom.
No, but now that we're starting to develop this really cutting edge technology and staying on top of it in the aftermarket world, I think a lot of guys still have no idea what you two are talking about with 1,300, 1,100, or 1,700
the higher the
milliliters
number, the better the
per.
No, let's dumb it down. Yeah.
So let's put this back to horsepower.
Okay.
Right.
Okay.
Stock CP3, I know from experience, I can get 600 rear wheel horsepower, pretty average.
625, sure.
Right.
Well, using one of these stock, we've been over 800 horsepower.
Really?
Yeah, but we boost the inlet. We watch the housing pressure.
Okay.
And we maintain the housing pressure at the highest possible value by having a variable speed lift pump. So when you supercharge the inlet under boost, as boost goes up, the if you will, lift pump pressure goes up. And it's something we rigged on the road race program back in 05, the GMC deal that we did. So we've been like 850, somewhere in there with one of these.
Okay.
Yeah. And I'm not talking board and stroked. I'm talking about a stock pump. So
outside of Banks's road race program, back in the standard,
we do it on the pro stock truck.
in the dinosaur aftermarket, stock pump 625, 10 millimeter pump, 800 horsepower.
Exactly.
We ought to make the pump and the controller for the aftermarket.
So we're talking this is 10 millimeter stock pump.
A dual pump setup is way more expensive than this boost thing, the lift pump. Right. So anyhow, I'm just throwing that out there. There's two pumps.
There's a different talk, a different conversation. But we're making the Denso. We're bringing it home on the Denso.
Well, I'm telling you, same with you can enlarge the Denso injectors. The limit of that we don't know yet, but there's some machined and not tested yet.
Sure.
So this thing's got some legs. I think you might be pushing. Now, we haven't run the boosting lift pump on this one. We've got to know a lot more about this pump before we do that. But
from the
from the get-go, this has I think it's around 3 atmosphere or 3 bar, like 40 to 45 pound requirement.
Oh, so it's got a lift pump requirement on it. Okay.
Yeah, it already requires that. So, and they may be varying the speed of that pump in the truck.
Right.
That I haven't discerned quite yet. So I think This thing's got some legs as a single pump racing
As
setup.
a single pump and able to go up on fuel pressure, which
Exactly.
means
The only other
don't need to go to
caveat
big
on this, the
injectors.
only other thing you got to watch is pump shaft speed. You know, these kind of go over the edge of the earth at about 4,000.
right, you lose your
RPM
efficiency
pump.
on the gear or in the pump.
The pumping itself.
yeah.
Supercharging helps flatten that out and extend it,
Sure.
the RPM range.
Yeah,
By
keep it
that I
linear.
mean supercharging the lift pump.
Right.
So there's a lot of benefits to doing that if you're running it in stock position. I hope the same thing happens here.
Yeah.
Any ideas on horsepower? Like where do you think? What does your gut tell you? Where do you think this will land on horsepower? Assuming this was 6 without supercharging the inlet
If
on
I
it.
can spin it enough, I'm thinking we could hit 1,000 horsepower with a single pump.
That'd be
But
crazy.
you're talking in
Because
a
you've got
belt-driven
headroom.
application, in a
I'm talking about something that might be a bandit street machine.
okay.
You know, I don't
Okay.
know. You know, it's you got a lot of emissions.
Dale's getting aggressive with us here.
Oh, yeah.
He wants 1,000 horse out of the stock
Well, I'm
pump.
talking-
I'm going to hold you to it, man.
I'm talking put in a pre-emissions vehicle.
Right, of
you
course,
know,
yes.
and have some fun.
Yeah, I get it. Let's take a look at the backside of these things,
yeah.
just for grins here. So they both have 3.
Yeah, this one
300s on
this one
three.
has. You can actually have a vacuum at the fuel inlet with this pump, less than atmospheric pressure,
Yep.
or slightly more, because it's got its own little gear pump on the back.
right.
So call that a second lift pump. That charges the housing and gives it the proper housing pressure.
Yeah, well, on an LML, you don't have an electric lift pump. This is the lift pump.
It sure is.
Right.
But when we run them on the dyno, there's a range. We put pressure to them. If you're going to do any kind of performance.
If you listen to the podcast, you know
Yeah,
the pressure.
you guys have
That's how you
talked
keep
about.
it
I'm sure
alive.
you've talked about putting electric lift
Yeah.
pumps.
Right.
So, and an enlarged in-tank
Sump,
pickup.
yeah.
Yeah.
This one doesn't have that. You've got an aggressive pump. You know, that's more like a gasoline fuel injection pump.
Okay.
You know, port fuel injection
Yep.
pump.
Yep. Yeah,
So-
you're talking 40 to 50 psi. I mean, that's
what we're talking about.
Our lift pumps on the
Right.
fast systems are in the trucks normally. I mean, we don't go over 8 to 11 psi maybe on a stock truck.
10 is where they're set.
Yeah.
Yeah. And that's the upper limit for that guy.
Right.
You don't,
No, you
don't
can't
want-
go more. You push the regulator open.
Yeah, you
Is
lose
what we run
control of
into.
the. Okay.
So I think we've covered it.
I was going to say, so this
More
covers.
flow capability, more rail pressure capability.
Summarize this in one word, right? It's overhead.
It's power overhead.
We have-
is
we have
exactly
power
what it
overhead.
is. Yeah, there's lots of
I'm gonna
it.
steal your word.
But I think what's going to be our limiter is that guy right there.
Well, before we dive into some of the other engine assembly, I want to know, what do you think are going to be some of the weak points that we deal with in the aftermarket world? So as guys are starting to buy L5Ps, they're starting to look at what's my build list going to be. Right now, they call me. I have very little information to give them.
Yeah.
What are you suspecting to be some of the failure points that my stock guys run into?
Failure points with the L5P. We haven't found any. The engine is, well, let me put it this way. A guy with decades of diesel experience was the chief engineer.
Right.
A guy with decades of high performance experience was number 2 in that group.
Okay. So
This whole
We got 17
thing,
years on the Duramax
Yeah.
at this point too.
plus you've got a guy that's second man in that design group who's a racer. And you'll see it as we go through this stuff.
Yeah. Yeah.
So I'm just saying, it's a very
Buy an
cool
L5P.
thing to have a racer designing a diesel engine. When Ford did their 6.7, the guy who ran that program, and I visited him quite often as they were
Yeah.
developing the engine, and we would talk, and then he'd buy me a bowl of chili. That was the payday. He came from Cosworth. Well, Cosworth, what do they do?
yeah.
Badass racing engines.
Right.
So you'll see Cosworth elements in a Ford 6.7 V8. It's kind of interesting all around.
Well, let's set up on we got the top end of the motor. We've established that it's well built. It's got overhead. It's It's exciting for the aftermarket. What's not exciting is we still don't have tuning for it, but
We'll get there.
c'est la vie. I kind of want to move over to the cylinder heads and just round out the top end airflow-wise.
Oh, sure.
Let's do that.
Yeah, let's do that.
Absolutely.
So we just took it from the top end of the engine with the injectors, the pump, the turbocharger, all the airflow. Right? And if there's one thing I've learned from you talking to you the last 3 episodes, it's all about maintaining that airflow through the whole system, through the whole charge air system.
No loss.
Exactly.
Yeah.
There's a big change going from the earlier cylinder head to this new cylinder head. It almost makes me see like small block Chevy to LS. But I mean, I'll draw your attention up to the clamshell here. Made a big change here in the plenum size and the clamshell design in the cylinder head. Talk to me about this, Gale. What are they shooting for here?
Well, essentially, they got rid of, by moving the turbo forward.
Yep.
You had to.
The relief there.
Yeah. The turbo's now here where the air used to enter.
Right.
So they moved to this forward position, which I love. I'm going to
cue a shot
use
of Banks'
that
big
for,
house
but,
manifold.
yeah, well, there's going to be some stuff. But basically, other than that, the cross section for flow is pretty much what it was. On the earlier heads, you know, you went in basically in the middle, or
right here.
Yeah, and then you went both directions. These heads have got, if you will, flow inhibitors built into the casting. This lightens the casting.
Oh, is that what that point is?
Well,
okay.
I guess. I mean, that's the only reason I'd do it.
Yeah, okay.
Otherwise, I'd leave it as is. And a lot of guys machine a little bell mouth radius around the ports to help get the air into them.
Yep.
And use the stock clamshells.
Very common to use the stock clamshell in pretty much any performance application up to...
You see a lot of it, but it really becomes a throttle.
Yeah.
Anything where the restriction is high, I call a throttle.
Makes sense.
There's no butterfly. It's fixed.
But it's choking you.
But, yeah. What they've done on the late head, on the L5P, is they've depressed this surface and actually taken the mouth of the intake ports deep into here. So you have a big cross section.
That's huge.
And less port distance to the valve. This is a huge change. From a racing standpoint, guys have done billet heads like this, similar to this. I've seen it. So it's not a new idea by any means, but the performance guy
and coolant.
The performance guy in that engineering group, I can just feel him here.
Yeah, like, did I get rights for that?
Yeah.
Or who's paying me for this?
It's very cool. The exhaust ports also flow a lot better, although the outlet looks very similar.
Okay.
And they've moved the bolts up on the top, which allows us in the aftermarket to.
There's an extra head bolt too, isn't there? Like
there's actually 2 extra head bolts. Yeah, and those 2 extra head bolts are right here in this corner and in this corner.
So we'll get
You'll
close.
See, they are not there, and the material's not there.
Right.
So gives you a lot nicer port dynamics into these end ports as well, where the clamshell here just ends.
Right. Well, it's usually a nice beat
you're
RTV.
actually you come down here and then do that.
Yeah.
Here, you're already turning. In other words, this is
the radius is already built into the head right there.
Yeah, and that drops the pressure, kind of helps it into that port.
So what we're looking for is a really consistent flow to all cylinders and a minimized
cylinder to cylinder flow, far more equal, even though you're
inlet's
entering there.
Yeah.
When we dyno an engine, we put a thermocouple at each exhaust port.
Okay.
And if you're on the dragster, when we look at the dragster, we have an O2 sensor at each exhaust port.
Okay. So reason for that obviously is to see is the output cylinder to cylinder.
We call it power balance.
Okay.
If you get your vibration dampener design correct, you're taking the twist out of the crankshaft.
Okay.
You're absorbing it.
Yep.
If you have a power imbalance, you're putting more into one throw and less into another, and you're inducing twist again.
Yep. Makes sense.
So you want perfect cylinder to cylinder fuel and air. And of course, you'll never ever get perfection at super high flow like this.
Well, it's not, I mean, but diesel head has traditionally been like the peanut port of the industry. You know what I mean? It's been embarrassingly small flow.
When we get on the flow bench, this will be kind of cool. One other thing they've done is the valve spring is a conical valve spring, or beehive style valve spring.
Okay.
The spring retainer is smaller, lighter. So I like this because inherently it looks like, hey, I can go to higher RPM. Mm-hmm. What you do is springs start vibrating at a certain frequency. And this takes that sympathetic frequency and spreads it out. Okay. So the spring, this is like NASCAR.
Yeah, we're talking
right
some
now.
high-end, high RPM
but all
stuff
I'm saying is this is that racer again.
Yeah,
you know,
well, you can tell.
Or his influence perhaps.
Yeah.
So they've done some incredibly sexy stuff. Bolt pattern is similar on the intake side, but not identical. So I think I pointed out all the differences. In terms of the strength of the cylinder head, I would bet $100 that this on the fire deck is a stronger cylinder head.
Okay.
The fire deck meaning this surface right here, because this engine is a much higher firing pressure design.
Yeah, we were talking about that. 20% higher cylinder pressure peak.
Nominally, yeah. This is like 180 plus atmospheres or bar. Yeah. The earlier one, I think, is in the 160s, somewhere in there. It's up considerably, and that's all I've got to say. So much stronger head gasket. If you're going to go racing, this is a hell of a place to start.
Yeah. Well, again, it looks like they built the overhead into the head flow.
Exactly.
As well.
Exactly.
And, I mean, guys in the diesel industry are going to see that in lower EGTs at higher power levels. Just a better run. I mean, a stronger engine at higher output.
As we'll see on the flow bench, this is way different swirl than this as well.
I had some really good discussions with you offline here about the crank and some of the differences. And we've talked a little bit about the oil assembly and some of the other internal lower end parts. Walk me through what our guys are looking at here. Okay. What do they get into? Yep.
Okay, overhead again. It's a much stronger crankshaft. The earlier crankshafts have a smaller pin, crank pin. And part of what makes a crank fragile or strong has to do with the overlap of the main bearing diameter and the pin diameter.
Okay.
So that is the earlier design up through LML. This is something we've been doing, which we call a big pin. And we've enlarged the pin, and it's a stroker, but the main journal to rod journal overlap, those two circles, overlapping each other, is part of the power flow through the crankshaft and makes the crankshaft stiffer, less flexible. Guys break Duramax crankshafts. There's a lot of reasons for that, and that's another discussion. But what they've done with this helps you maintain them. So the earlier rod, the LML, is a conventional rod, but as you go bigger, the section across, this is a plastic model of a rod we've done, the section across the rod gets so big, if it's a conventional rod like this, that you can't put it through the bore to assemble the engine.
Okay.
So, you know, a lot of people think, oh, that canted rod is much stronger. Well, perhaps you've got a bigger bearing and a smaller bore. You see this on a lot of diesels. It's not a new idea. So we designed a rod to go with ours, which is this guy. This is a kind of a billet rod. And we designed our own rod bearing.
Well, you know, I can see one of the immediate differences is just in the actual length of the rod, the girth right here.
Yep.
Obviously, we're going to get more durability out of something that has more material. What kind of drawbacks do I have to going to an aftermarket rod like this?
Well, usually we try to make the design as light as possible.
Okay.
And we could put these on the scale, but the aftermarket rod, of course, there's one available for a stock crank.
Right.
You're wasting your money to do the angle cap with a stock crank, unless you've stroked it so far the rod's hitting. We did it for engine durability, where we're really pushing the Duramax design. You know, and I want to push real hard with the super turbo we're doing in our dragster. Also, I need crank durability for engines I do for the Navy or for marine use. So that's why we did it. The guys at GM did an even bigger journal.
Right.
And that's all about, you know, this peaks at 2,800 RPM.
Okay.
They designed for that. There's a thing called bearing surface speed. If you get too high, it doesn't lubricate well.
That makes sense.
So for racing, I didn't go that big. I consciously kept it to this because I want to turn my racing engine 7,500 RPM nominally. We're at 6,300 last time out. So anyhow, this is a powdered metallurgy rod. Some guys have some fear of this. I don't have any fear of it at all. In fact, it's, for all practical purposes, a forging.
Right.
The thing is an incredibly strong rod. So they've really done the big pen.
Yeah.
And I think this would be good up to maybe 5,000, 5,500 RPM momentary. Once we get these out into the aftermarket, and guys are racing with L5P basis, you're going to see these things being buzzed something fierce.
You think so?
Yeah.
These will be the big deal, huh?
Well,
These guys finally won't be snapping
I think somebody will find the maximum bearing speed and spin some bearings. Yeah. So as far as the rest of this, talking about lubrication, the oil pumps, we knew something was up a number of years ago. We made a pump with wider gears.
Okay.
Because I needed more piston cooling nozzle, more piston cooling flow, so we didn't melt the pistons.
That makes sense, yeah.
And so we enlarged the nozzles and removed they have a check valve in them. We removed those. That also helps maximum flow. So we made a wider gear pump. They've done the same thing. They've done a wider gear pump, and with the camera you can't see it, but this is about 20% wider than this.
I mean, it's significant. Yeah. I mean, you can, naked eye, you can see that there's a
easily
difference here.
see it.
Okay.
The housing and the fluid dynamics in the housing have also been changed. The pressure regulator hangs straight down into the oil sump.
Oh, okay.
So you know we've done a new lower oil sump, but we had to use their height because that guy is right in the front of the engine.
It's there. It's mounted.
Yeah.
Right.
The other part that gives me some hope for high RPM out of this is here's the lifter in all the engines up to LML.
Right.
It weighs about the same as a small block Chevy piston. I mean, it's a heavy Rasco.
Let's see that.
Yeah.
Wow. It is.
And here's what they've done on the L5P. Now,
well, that's nothing.
And here's one of our pro stock racing lifters. So essentially, and they're rollers and they're guided with this nylon. I assume it's a nylon material.
Right.
Guides the rollers so they don't rotate. This is real proven GM technology. Yeah. You know, the LS engines.
I was going to say, this has been around for a while too. Okay.
And then this is GM Pro Stock. So racing. But look what we've got here. My God. That's RPM. That's more RPM. Now, they're both solid rollers. There's no, hydraulic lifter involved here. So quite a change in oil capacity. We're going to do a second external oil pump.
Okay.
Because we're going to increase the piston cooling once again. And we're looking at steel pistons, but let me tell you what's going on with the pistons. The pistons have changed in that this surface right around the combustion bowl is kind of lasered. In other words, they make it tougher after the piston is cast, and then they machine the piston. So that gives it more thermal capacity.
Sure. So it's not going to crack due to heat at as low of a temperature.
Yeah.
Okay.
And
this is the stock L5P piston?
It is. Mm-hmm.
Yeah, I mean, you definitely can see some differences in it.
This is the earlier piston. Of course, this is one of my stroker pistons, but
this
has valve release. But this is based on a different design entirely.
Sure.
And higher lift valves. The wrist pin is different. It has a diamond DLC coating on the wrist pin.
Oh, really?
Yeah.
Oh, wow.
Yeah, for production engine, it's got some, the coated piston skirts.
Yeah, I mean, these are things we used to do to LB7s when we were first trying to figure out how to keep those things together.
There it all is.
Yeah.
And of course, they've maintained this cast in, if you will, steel or cast iron upper. I'm not sure what they're using, but much better. This is our steel piston, and it's also oil cooled.
Okay.
But way the hell tougher. This is from a design we did years ago with Molly for a marine engine I did for the Navy, a Cummins-based 5.9 marine engine.
Okay, yeah. I think we've talked about that in the podcast before.
And this is machined off the Cummins forging.
Really?
So it's a little heavy for the Duramax, but we're running piston life study with them.
Okay.
And then we'll do a forging that's dedicated. So we've kind of covered the interior, the oiling. The oil cooler on the engine is 20% bigger nominally. Oil pump's bigger. So they've covered about everything. More piston cooling, more pump to cover it. The camshaft is not radically different.
Right.
It's different in that the lobes are different for the smaller radius roller tappet, but that's about it.
Yeah.
Water pump also much bigger. It turns a different speed, much bigger impeller in terms of not diameter, but depth.
Right.
So a lot more water flow capacity as well. You make more power, you're rejecting more heat, and you got to have more radiator to handle that.
Well, I guess that's what's been interesting to me is that general concept about the L5P is they've added about 50 horsepower, 40 horsepower, whatever they're rating them at. But yet, when we add 40 or 50 horsepower to an LML with a Banks tuner, with a Duramaxtuner spade,
whatever it is,
we're not doing all of these oil adjustments and water pump adjustments and redoing the pistons and all of these other intricate details. It makes me think that this platform has a lot of capacity to go up.
Everything's up like 20% except the horsepower.
Right.
They're only at 445. Nominally, they started at 400. So they're up 10, 11, 12%.
Right.
Headroom.
Yes.
Yeah.
Okay. I'm excited.
I'm not informed. I'm just guessing. 500 horsepower and 1,000 pound-feet will be the price of admission in the diesel pickup truck market in a few years.
Oh yeah, I mean we're rapidly going there.
You got to go there.
Right.
The first one that gets in, they're going to have bragging rights for about 15 minutes.
Well, yeah, exactly.
And then everybody else is kind of.
Cummins last time Cummins got beat out by Duramax, they literally just re-released their truck with a different tune on it that gave it the HO. You know, the high output.
Ford did that on the 6.7 when the Duramax got them.
Yeah, same stuff.
They had a higher power. In fact, PickupTrucks.com came here.
Really?
And we dynoed, went to the Ford dealer, loaded the new cow, came back, dynoed. They sent the numbers to Ford. They said, they've got a good dyno because it matches our numbers.
Right.
So this is fun. because this is horsepower wars in pickup trucks, and I love pickup trucks.
Oh my God. Who would have thought when they first put out a 12 valve with 100 horsepower, 190 horsepower, or whatever, that we'd ever get to this point where now we're driving 500 horsepower monsters that look like they have the capacity for what we used to build a motor with.
Well, you look at Cummins. That JI case gave Cummins money to, I think they co-developed the 5.9.
Okay.
For a farm tractor. And I think it was more like 130 or 135 horsepower.
I think you're right. I think the original was, yeah.
And then there's guys using the later, like 6.7 cylinder case, even the 5.9 cylinder case. And for our marine engines, we did a CGI cylinder case, which is much stronger, cylinder block. There's guys way up in the thousands of horsepower with the Cummins. The real duke out. And I'm just so happy that Dan Scheid accepted. We're going to race each other.
Oh, really?
Yeah, and I think that will draw a crowd.
Yeah, I'll be there.
Duramax versus Cummins.
I'll be there for sure.
His dragster is a record holder. And I want to go out and have some fun, hang out with Dan. He's a good guy. And whoever is the cleverest will probably kick the other guy's ass. But I think I can get it kind of close. And the real benefit will be the aftermarket and the enthusiasts.
Oh, God, yeah. I mean, like you said,
I think I'll have to tow to Indianapolis to race him the first time. But he's agreed to it.
That's awesome.
Yeah. It's a few years ago. We've been doing the L5P development for a few years.
Right.
And now there are military vehicles delivered to the Marines with a Banks L5P.
The Diesel Performance Podcast is brought to you by Calibrated Power Solutions, home of Duramaxtuner.com. Calibrated Power develops emissions-equipped calibrations for a wide variety of diesel powertrains, including Duramax, Cummins, Power Stroke, John Deere, Case, New Holland, and many more. For more information and the best customer service in the industry, check out calibratedpower.com or call 815-568-7920. That's 815-568-7920. If you'd like to contact the podcast, send us a message through Facebook or email Paul at Duramaxtuner.com or Chris at CEHMKE@Duramaxtuner.com. Hey, thanks for listening. Your feedback is appreciated. Please rate and review us on iTunes, subscribe on YouTube, like us on Facebook, and by all means, let us know if you have any ideas for a podcast. We'd love to hear from you.